What's up, team? Today we're going to talk about transformations. You'll see the learning target above me. I can perform a transformation from a given pre-image and a function, and then I can determine if the transformation is rigid or non-rigid. So here's kind of the gist of what we're getting ourselves into today. Say we have a Cartesian plane here. Say we have a beautiful Lion King coaster as our figure, and we wanted to perform some transformations on it. Well, what's a transformation? All it is we can move it around. So maybe it moves right there, or maybe it moves over here, or maybe it moves up there. Those are all transformations. The size and shape stays the same. We're just moving this thing around. Another type of transformation is we could spin this thing. We can rotate it 90 degrees counterclockwise. We can rotate it, if we keep rotating it, we can rotate it like an odd measure, something like this. These are all different examples of transformations. Another type of transformation, say we have this, it's sitting right here, the Lion King coaster, and we wanted to reflect it around the x-axis. We could do something like this, and it would actually spin around, so it would be like this. And we're seeing the backside of the coaster. We can do that with shapes and figures as well. There are a few other types that I'm not able to show you with a coaster. The ones that I just showed you, we call non-rigid. We'll define those here shortly. But there's other ones where we can actually take the original image and stretch it out, make it bigger, or we can squish it or compress it down. I can't do that with this coaster here, but we'll be able to see that with some other examples here shortly. Okay, we need to define some terms. This is all the defining that we have to do today, so I'm throwing it all at you at once. I'm going to read through it. Feel free to pause, feel free to rewind, do what you need to do. So at the top here, transformation is a change in the position, size, or shape of a figure. That's all the stuff I just showed you with our Lion King coaster. We say that the pre-image of the transformation is the original figure, and the image is the figure after the transformation. So earlier I showed you the Lion King coaster. Wherever it started, that was the pre-image, and then wherever it moved to, we'd say that that's the image. So whether it's just a straight move or a rotation, so pre-image, image, or we can say pre-image, image, because it rotated around, whatever the case may be. A rigid motion, that's a type of transformation that preserves the exact same size and shape, only the figure only changes location. So you saw that when I moved the thing around. That's the same with the flipping. That's all the stuff I could do with the coaster, because it's not changing size or shape. I'm just moving it around. And a non-rigid, that's the stuff I couldn't show you with my coaster. That's what actually changes size and shape. Sometimes it grows, sometimes it shrinks, sometimes the size itself just changes, or the shape itself changes based on what you're told. Then I have examples here: sliding, rotating, flipping. I showed you all those things with the coaster. Non-rigid motion, it stretches, or it compresses, or squishes. Okay, let's do an example. Say we were given this rectangle here. It's got vertices at 2, 0, 2, 4, 5, 0, and 5, 4. This is our starting image. This is what we're given, so we call this our pre-image. Whatever transformation takes place, it's based on this, and whatever that shape is our our image. This is our pre-image. So the function that we're given here, we have x, y, and then it has this arrow. Now, the way that we pronounce that arrow, we say goes to. So it's x, y goes to x, comma, y minus 5. So what this is saying here is that the x coordinate is saying the exact same thing. The x coordinate doesn't change. The y coordinate, however, it goes from whatever it was in the pre-image, and then we're taking away 5 from it in the image here. So thinking about that, thinking critically outside the box a little bit, if the x doesn't change, that means that this thing can't move left or right, because the x is staying the exact same, but the y value is changing, so it's moving up and down just somehow. How? Well, we find that out because we're subtracting 5. So if we have this image here, and we're just going to move the whole thing down 5 units. So what that looks like, I'm going to walk you through the whole thing instead of jumping right to the end here. We can take, we'll start with this point right here, 2, 4. If the x coordinate is exactly the same, we're just going to take 5 away from the y coordinate. So our new, the image of this particular coordinate is going to be 2, negative 1. The x doesn't change, but the y, we take away 5. In the same way, we're going to have 2, negative 5. And then we're going to have, 5, negative 1. It's going to be here. And then we're going to have 5, negative 5 down here. So our image is this blue one, whereas the pre-image is the black rectangle. We classify this as a rigid motion because the whole thing, it just moved. It didn't change size or shape. Okay, here's our next example. We're going to start with the same pre-image here, but we have a different function. This time, xy goes to x minus 6 comma y over 2. Much more complicated this time. So we're going to have to deal with both of these coordinates. Something is going to happen with each of them. So let's walk through each of these pieces. What's going to happen here? Well, for the x coordinate, we're just going to take away 6 from it. So this point here, the x coordinate was 2. It is now going to be negative 4 because we're taking 6 away from it. And the same is true with all the others. We're just going to subtract 6 from the x coordinate. Easy peasy. The y coordinate, however, we're going to divide by 2. So that means the y coordinate of this vertex up here, or this vertex up here, is going to be 2. Same is true with this one. And then 0 divided by 2, that's a little sneaky, it's still 0. Okay, just for the sake of time, down here at the bottom, I made a table of where each of these vertices are going to go based on our function here. So I took 6 away from each of the x coordinates. 2 turned into negative 4, 2 is negative 4, 5 is negative 1, and 5 turned into negative 1 here. Okay, so we just took away 6 from all the x's. Easy peasy. At the same time, I divided each of the y coordinates in half. So the 4 turned into a 2, the 0 stayed 0, 4 turned into 2, 0 stayed 0. So this here, these are the vertices of our image. Let's plot these points real quick. Negative 4, 2. 1, 2, 3, 4, 1, 2. Negative 4, 0, right here. Negative 1, 2, negative 1, 2, and negative 1, 0. Boom. So our image is the one that's here in red. And this is what it looks like. So you see that it was shifted left, and it was also squished in half. It's half the size. So we'd say that this is a non-rigid motion. Even though the width here is the same, you'll notice 1, 2, 3, 1, 2, 3. The width is exactly the same, but the height is obviously different. It's half the height. So this is an example of a non-rigid motion. Okay, rigid motion, non-rigid motion. Rigid motion is when the shape moves around, but it doesn't change size or shape. Whereas a non-rigid motion, it changes size and or shape. Okay, you got this. Let me know if you have questions.